Hello, chemistry class periods. I'm sorry I'm not going to be there today, so I'm making a video for myself and Miss Rao for chemistry. Right now what you should have out is a bell ringer, a pen or pencil, and a periodic table. Other than that, you don't need anything else right now, so I'll give you about 30 seconds. Go ahead and take those three things out. So you can see from the slide that this is our first common assessment bell ringer. You can go ahead and label that on your existing bell ringer. If you need a new bell ringer, there are some in the drawer closest to the door. You can go ahead and start that. If you just finished, I will collect them tomorrow. Obviously this is a really long question, so I don't expect you to write down the whole thing, but make sure that your question space on your bell ringer has at least the data chart. Alright, I'll give you guys about 3 minutes to work on this bell ringer, and then we'll discuss it. Alright, so if we look at this question, we can see that it's asking about the difference between ionic compounds and molecular compounds. We actually did a lab on this a long time ago with salt and sugar. So this is kind of accessing that old information. That's what Common Assessment Review is all about, like accessing that old information. So if you're looking at each of the compounds, you can see that the compounds that are ionic, so K2CO3, the first one is ionic because potassium is a metal and carbonate's a nonmetal. CoCl2, that's cobalt and chloride, those are ionic compounds, and ammonium chloride is also a ionic compound. Even though it's got no metals in it, ammonium NH4 is positive, so it actually acts like a metal. So those are the three that are ionic. You can see the molecular ones, C2H6O6 and N2O4, both have relatively low melting points compared to the ionic compounds. So that's where you should start. If you're looking at that answer choice, it's actually F is the answer. I imagine some of you were leaning towards H as well, that ionic compounds with polyatomic ions have the highest melting points of all compounds. While that's true in this data table, there's a lot of other compounds out there with polyatomic ions, so they might actually have different ones with different melting points, so you don't have enough data to make a statement with H, but I understand why you would pick that. The answer is actually F. So what I want you to do now is write a sentence explaining the answer, and just, if you had the right answer all along, just like elaborate on it a little bit further. And for those of you that were incorrect or didn't know, make sure you write a sentence. I'll give you 30 seconds. So here's what's happening today. Today we're learning about something called significant figures. It's going to be kind of an abstract concept to you because you probably never thought about answering questions and with these sort of figures afterwards. We're going to take some very brief notes on page 4 of your new packet that you just got when you walked in the door. We'll watch a quick YouTube video on why significant figures are important. I think the guy in the video does a really good job explaining it. And then you'll take a little exit ticket at the end of class. You'll probably have some extra time, so I have an article for you to read. Or if you'd like to work on something else during this time, like if you have a book for English or if you have something else, we can have some silent study time at the end of class. I'm not there today, so I don't want to cover up too much material, but we can definitely get through this even though I'm not there. As you can see, there's no homework at the bottom of the page, so don't worry about homework tonight, at least for chemistry. Tomorrow we'll probably incorporate some different practice. So, introduction to significant figures. So at the top of page 4, you'll see where it says Notes on Significant Figures. I want you to use one of the rulers at your table to draw a line that is 6 centimeters long in the space below. I don't care which of the rulers you use. There are 3 types, A, B, and C. The idea is that everybody's supposed to have a different line. So whichever ruler you get, that's the one you get, and just draw your 6 centimeter long line. Okay, so I'll give you 30 seconds. Go ahead and draw your line, 6 centimeters. So look at your ruler that you just drew that line with and your table mates. Why don't you take 30 seconds as a group, compare the length of your lines and the rulers that you have and notice the differences between the different rulers in the different bags. Alright, as you can see, all the rulers were different. Some of them only had a 0 and a 10, so you had to really estimate where 6 would be. Some of you had 6, but was it 6.0 or 6.00? Or there's different measurements for different rulers, right? It's all about precision. So this is what we're kind of moving into. We're moving into a more mathematical, measurement-based kind of chemistry now. And so it all depends on the tools that are at your disposal. So if you drew a line that was 6 centimeters, that would be ruler A. Right? Ruler B would be the one that had the single digits but nothing else. And then finally ruler C would be the one that was the most accurate and the most precise, that had 6.00. It had the most little lines on there to differentiate the distance a little better than the others. So we're still at the top of page 4. I want you to fill in the blank space where it says to convey information about the precision of the instruments, scientists use significant figures. Significant figures include all of the digits or numbers that the scientist knows, plus one more that was estimated. Essentially, significant figures just give us an idea of the precision of the instruments that the scientist used. So there's a lot of unfamiliar vocabulary coming your way right now. Don't panic. It's perfectly fine. I promise you this is not as complicated as it seems. Alright, so how do you determine significant figures? It depends on the numbers that you have. Basically, what I want you to do right now is at the bottom of the page 4, you'll see 6 numbers, starting with 0.0506600 and then ending with 9980. I want you to place those 6 numbers on the left or the right of the picture of the United States based on whether you see a decimal or not. So for instance, the Pacific Ocean is where the decimals that are present are going to go. So anything that has a decimal, if you can see a decimal in the number, you would place that on the left. If you don't see a decimal, you're going to place it on the Atlantic side, so the decimal is absent, right? So the P is for Pacific on the left side, the A is for Atlantic and absent on the right side. Okay, so for instance, the first 2 numbers, I'll go ahead and place them for you. I'm going to place this one, 0.050600 grams, on the left side because I see a decimal, and if you look at the number, you can see a decimal right there. If you don't see a decimal, like in 600 milliliters, you're going to place that one on the right side. So at the bottom of your page, there are 4 more numbers. I want you to place them on the left or the right based on whether or not you see a decimal. I'll give you, this is so easy. I'll give you 30 seconds. I think that's enough time. So if we're going to place the... Sorry, I'm doing this during study hall and they're all being very patient listeners, but I'm just so hilarious they can't contain themselves. Alright, so we're going to put 2 more on, or we're going to put the rest of the numbers on either the Pacific side of the decimals present. So you should have 10.0 and 0.0021 on the left side, on the Pacific side of the United States. And on the right side, we're going to put 700,800. So it's 700,800 grams on the right side because there's no decimal, and 9980 on the right side because there's no decimal. So left side, decimal. Right side, no decimal. That's all you really need to know for right now. The picture of the United States, you're probably wondering, like, what the heck does that have to do with chemistry? It's just something to help us remember. The Pacific Ocean's on this side, the Atlantic Ocean's on the right side, so it's like left, right, if you're looking at the states. I don't know. It's okay. It helps, I guess. Step 2. To determine the number of significant figures, start on the ocean side of the number and find the first non-zero. Okay, so a non-zero is any number that is not 0. Alright, so if you're looking at the number on the left side, you're going to start at the 5, right? Because the 5 is the first non-zero that you see. Right? Because you're coming from the left, so follow my cursor here. As we're coming from the left, right, there's a 0, that's the first non-zero. So that's where we begin counting. That's our first digit. That's digit 1. Everything after that, including the zeros, counts. So 5, 0, 6, 0, 0, all count. So there you would have 5 significant figures. I want you to try this with 10.0 and 0.0021. At the bottom of your page there, it asks you how many significant figures are there for each one. Remember, start counting at the first non-zero, and everything after that counts. I'll give you 1 minute to try these 2. You can definitely work with a partner, and if you're just confused, just hold on for 1 second and we'll do 2 more examples. Okay, so looking at the number 10.0. So since it's on the left side, right, because it is the decimals present, we're going to start from the left, and again, follow my cursor here. The first non-zero we see is 1. So everything after that counts. So we have 1, 2, 3 significant figures. For this one, we have 0.0021. So again, we're going to start counting at the first non-zero. So I'm going to stop when I see a 0. 2. 2 is the first non-zero. Everything to the right counts. So 1, 2 significant figures. All right. On the right side, here we're going to we're going to count from the right. So the Atlantic, there's no decimal here. The decimal is absent. And the first non-zero we see is where we're going to start counting. So we're going to come in from the right. That's a 0. That's a 0. 6 is the first non-zero we see. There's no numbers after that, so there's only 1 significant figure here. All right, I want you to try the next 2, and again, I'll give you 1 minute. Actually, I'm going to run out of video, so I'm going to start another video. So while they're starting the other video, you should be able to finish those 2.